So how to represent, how to marking a grinding wheel? So marking means, so when you are purchasing the grinding wheel, or when you are specifying a grinding wheel, there is a standard notations are there on by every manufacturer. So those notations, I think some students may be aware about that. Some students are, because last class when we taken this, maybe there is some kind of network issues was there. So that's why I thought again I will try take this, because this is one of the most important in grinding wheel. So as per Indian standard, so as per Indian standard IS 551, specified in 1954, this is specified a standard system of marking the grinding wheel. So there is some 7 digits or 7 indications are there. So according to this system, the following elements are represented in defining in a particular definite order. So in that 7 things are there. So first one and last one, if you remove it, most important thing about the grinding wheel, the basic 5 parameters, at last 5 specifications of the grinding wheel is mentioned in this marking scheme of any grinding wheel. So that if you see an example, this if you see most important thing, maybe you can see in this example. So this grinding wheel is represented by this. There is some numbers will be there, and as well as some letters will be there. So like this, maybe you can see. So like this, it used to specify. So some numbers as well as some letters are there. 8 minutes. So this is, you see here. So this is one number. This is 1, 2. This is 3, 4, 5, 6, and 7. Total 7 is there. If you remove this last number as well as the first number, so these things are represented by manufacturer specifications. So other than these 3, whatever the 5 indications are there, so these 5 indication is representing these 5 specifications of a grinding wheel. So most important thing in any grinding wheel is there, it's abrasive material. So normally grinding wheel is made of abrasive particles, or nothing but abrasive grains, which is bonded together by a bonding medium. So most important thing, so most hardest material in grinding wheel is abrasive particles. So these abrasive particles, different types of abrasive particles are there, natural as well as artificial. So in natural, we have seen sand, diamond, natural diamond, all these things. Similarly, for artificial, silica carbide, aluminum oxide, even artificial diamonds, all these things we have seen in the last class. So which that particular grinding wheel is made of which abrasive material? So that is represent, that has to represent in this marking scheme. So when you're buying or when you're taking a grinding wheel, you're supposed to know which kind of abrasive particles are there in that grinding wheel. So that's the first thing. So after manufacturer specification, my first thing is, so a type of abrasive, then grain size, or nothing but grit. So grain size means, so what is the size of the grain, size of the abrasive grains? Very small or very big? So very small means, so it is the finishing is good, but material removal rate is less. So grain size, and the third one is the grade. So grade is nothing but how hard or how strong your grinding wheel. So that is represented by grade. And then structure. So how this grinding, this whatever the abrasive particles are distributed on the wheel. So grinding wheel. So in 1 square mm, or maybe 1 square centimeter, if you take, how many number of abrasive particles are nothing but cutting edges are there. So that is represented by structure. And third, last one, fifth one is, so bond. So which kind of bonding material? First one is abrasive material. Fifth one is bonding material. So which kind of bonding material? Maybe last class we have seen different types of bonding, well, rubber bond, silicate bond, shell-lock bond, different kind of bonding material we have seen. So which type of bonding material it is there? So every bonding material is represented by one letter we have seen last class. So the same thing is there. So if you say in this, the same kind of things are there. So these center 5 is represented, whatever the 5 we have seen. And first one representing the manufacturer symbol. So who is the manufacturer? Manufacturer maybe some XYZ manufacturer, or maybe some ABC manufacturer, or some kind of manufacturer, whatever is available in the manufacturer in the industry. So those manufacturer symbols will be there in first letter. So after 5, so whatever we have seen. So this abrasive. So here, if you see in this example, A represent aluminum oxide. So by seeing this grade, this specification, you can say that, so this grinding wheel is made of an abrasive particles which are aluminum oxide. And after that, 36 is nothing but your grain size. So grain size are nothing but grit. So 36. So 36 normally we have seen last class. So 36 means it's a medium type of grains. So as this number is increasing, so then you can see that the size of the grains are decreasing. So number whatever is there, so this number is quite inversely proportional to the size of the abrasive particles. If his number is smaller means, so size of the grain is bigger. If number is bigger here, for example, instead of 36, if number is 60, means your grain size is very fine, very small grain size is there. So this normally this number is represents in one square volume how many number of particles are inserted. So if this number is decreasing means that standard volume you are inserting only less number of grains, means size of the grain is increased. If it is a bigger number means that standard volume you can accommodate more number of grains. So when accommodate more number of grains means it has to have a small in size. So as number is increases means your size of the grain particles are decreasing. So remember this. So 30, if it is, for example, it is coming 20, means the grain size is bigger. It's not a medium. 36 means medium. So last class we have seen up to 30, it is considering as a coarse grain or nothing but bigger grain. From 30 to 60, we are considering as a medium. So above 60 is considering as a fine grain. So this number, so whatever based upon the number, you can come to know in that grinding wheel. So which kind of grain, what size of the grain particles are available in that grinding wheel. And next is the grade. So L is nothing but grade. So grade is nothing but strength of the grinding wheel. So normally for soft grinding wheels cannot use for hard material. So if it is say L is nothing but medium. In that A to Z number is indicated. Last class we have seen. So A to Z. So if it is starting, so A, B, C means it is it is soft wheel. As it goes end of the letters, then it is become hard. So L is nothing but it's coming in center of the alphabet. So this is considering as a medium. So medium grade. And third one is structure. So structure is nothing but 5. 5 means it's very dense structure. Means more number of particles or more number of cutting edges are there in a unit surface area. Similarly, V is representing vertified bond. So type of bond. So last class we have seen different types of bonds. So V represents vertified bond. Then 40 again. So last, whatever the seventh digit. So again it is represented. So manufacturer symbol. So first one representing manufacturer. So manufacturer symbol. So which kind of means which manufacturer, and last digit is manufacturer representation, means manufacturer give one number to represent that grinding wheel. So this first one is representing manufacturer. So manufacturer XYZ or ABC or maybe some motors, some Hyundai or something, whatever the manufacturer name is giving. And this last one is nothing but the manufacturer is giving one symbol to his references, because one manufacturer, for example, 51 manufacturer is not manufacture single grinding wheel. He manufacturing different types of grinding wheels are there. So each grinding wheel he is giving different notation or different symbol or maybe different number he will give. So that number is represents. So first one represented as manufacturer number, and last number is represented by number given by the manufacturer to specify that particular grinding wheel. So these things are very important for you. Definitely one questions may come. If any question will come in the grinding, so definitely one question will come. Definitely in gate, maybe you can expect at least a question from this notation, standard marking system for a grinding wheel. So if anybody having any confusion in this, ask me. So if not, maybe we'll go for next slide. So every students, please pay attention in the class. So just assume this is your regular class in classroom. Don't take it as lightly. So because I already repeatedly I'm telling, so there is no chances are there to conduct any offline classes in the college. So whatever we are taking the classes, considering it as your final class. So based upon this class only, tomorrow you're going and write the exam. If you're not writing if you're not understanding properly, you may not write the exam. So then it's very difficult for you. Already you've seen your results of the students who's written the exam after lockdown. So don't take easily. If you feel that you're going to pass easily because of pandemic, maybe people will consider that may not possible. If you don't write the proper answer, don't expect that you're going to get the marks. So be careful. Try to understand the subject. Pay attention to the topics, whatever the things are coming. If any confusion, ask us. Without your attention, without your involvement, nobody can do anything. So please be careful. Take subject seriously. Take your online classes little more carefully. Don't take it casually, even though you're taking from your home, even though you're taking from your wherever you're available. So don't take it just like that. Just log in and keeping side and you're doing whatever things that may not work. So this is a standard marking system. So whatever it's on, the same thing is there. So here one more symbol is represented. Types of abrasive 51. So manufacturer symbol. So nature of abrasive, A is representing aluminum oxide. Similarly, silica carbide is represented by C. So like this, you can symbols is there for nature of abrasive or nothing but types of abrasive. Then grain size. So here is representing grain size. So medium. So 30, 36, these things are coming in medium. So if it is further increasing, 70 to 180 is considering as a fine, and 220 to 600. So even still very, very fine grain structure. And 10 to 24 is considering as a big grains, and nothing but your coarse grains. So similarly, grade, so L, so ABC here, you see here, the grades are represented in this form, A to Z. So if it is starting of the alphabet.
Same way as emery paper.
Yes, any question?
Same as like emery paper.
Yes, same as the emery paper. Emery papers also same thing. In that also you used to have some kind of abrasive particles are there. Maybe you can see if you rub on emery paper, you can see some kind of small particles are stick to the paper. Same thing in grinding wheel. In emery paper, you are having very fine. So maybe your fineness may be somewhere about 600 to 500. But in grinding wheel, because it's a wheel, so that size of the abrasive particles are a little bigger. So same thing is as emery paper. Emery paper is flat, it is in circular shape. That's only. Right? So emery papers also you have a grades. So similarly here also you having a grade. So grade A to Z. If you take something about U, V, W, X, if you take, so this grinding wheel is very hard. Normally this, so whatever is coming this side, so this material is using to grind hard material. So hard material like tungsten. So like maybe cast iron or maybe your hard steels, high strength steels. So we are using whether it's this side, so whatever A, B, C, D, E, if it is there in the grade, so this is very soft. So means this kind of grinding wheels are using to grind the soft materials like aluminum, maybe magnesium, or maybe even for plastics. So plastics are also very soft material. So that kind of very soft material you're using. In between, so if it is coming, for example, in this, you can take it is a letter is coming as L. So L means it's somewhere about coming in medium, right? In center of the alphabet. So this medium grade. So medium grade is using to grind the medium grade material like mild steel or maybe copper. So this kind of material we are using, right? So similarly for structure, so structure is nothing but the distribution of material. So distribution of your particles. So if it is 0 to 7, so the structure means it's dense. If it is 8 and above the number, it's considering as open structures. Means number of particles, distance between the particle to particles is higher. So nature of bond. So already we have seen in last class different types of bonding medium or bonding materials are there. So vertified bond, silicate bond, rubber bond. So each bonding material is represented by a letter, a single letter or maybe double letter. So that letter, if it is show, means that particular bonding material is there to bond these kind of abrasive particles. So it is mentioning as V. V means vertified. If it is S, it's silicate. If it is R, it's maybe rubber. If it is a B, if it is a resinite. So these kind of things. If it is E, it is shellac. So different properties and different how to make these bonding materials we discussed in the last class. So if you want any confusion, maybe refer your textbook. So maybe you can see my videos maybe after I upload in the YouTube channel. So this is manufacturer specification. This is the types of the first letter whatever is there. So that represents the manufacturer symbol. So this is manufacturer symbol. So this is for manufacturer record whatever the symbol manufacturer is giving. So this here the number is giving or symbol is giving to the manufacturer. So representing, for example, your Honda. Right? So Honda is represented something, some number you given for 45, 46, 70, 90, whatever the number is given. So that number represents the grinding wheel manufactured by these manufacturers, maybe Honda, right? So, but in Honda, we having now, they used to manufacture different grades of grinding wheel. So these companies provide some different kind of gradings for each different type of grinding wheel. So that is represented in this. So these two is represented manufacturers, and these 5 properties is represented to specify the grinding wheel. In terms of abrasive material, rubber material, bonding material, grain size, grade, structures, all these things. So this is very important thing. So please try to remember, if possible, to take this as a screenshot. So then later maybe you can note down in your class notes. So now I'm going for next slide. Then these things also I think we discussed. Specification of the grinding wheel. So previously the marking, the nothing but marking system. So how the marking system is there, but how to specify the grinding wheel. So this is the specification. Every machine tool we are seeing how to specify the machines. So similarly for grinding wheels also, grinding machines. So it's need to specify when you what type of grinding wheel, what type of abrasives, all these things are important. In addition to that, when you're buying a grinding wheel or when you want to install a grinding wheel in the factory, in the workshop, you need to have these things to specify the grinding wheel. So that is the standard wheel marking. That is first most important thing for specifying any grinding wheel is marking scheme. Whatever just in previous slides, previous slide we've seen. So definitely that is important. That's the most important thing to specify a grinding wheel. So in that grinding wheel, what is there? So what type of abrasive particles, what type of bonding material, structure, grade, all these things are there. So that is the first important thing to specify a grinding wheel. So in addition to that, so few more things also is required. That is diameter of the wheel. So nothing but size of the grinding wheel. So when you have a grinding machine, so most important thing. So after the specifications of the grinding wheel, next important thing is size of the grinding wheel also. So in previous specifications, scheme of specifications, so these things are not there. So when you're buying anything or when you're installing a grinding wheel on a motor or a machine or in a workshop, you need to have these things also. Diameter of the wheel. So what is the diameters? Whether diameter is 200 mm or maybe it's a 2 meter or maybe it is 1 meter. So what size of the diameter, the size of the wheel? So that is also one of the important specification. So previously marking scheme. So marking scheme, and these are the specifications, diameter of the wheel. And third thing is the bore diameter of the wheel. So bore diameter is nothing but internal diameter. So based on the bore diameter only, you can mount this grinding wheel on an axle, right? So bore diameter also important. So if it is a big grinding machine, you need to have a bigger bore diameter. If it is small bench type or maybe pedestal type grinding machine, which we have seen in last class, so if that is there, you need to have a smaller bore sizes. Then thickness of the wheel also important. So nothing but your width of the wheel, width, or maybe here we can call it as the thickness, how much width the grinding wheel. So depending upon the width of the grinding wheel, your machining time will be depends. If the grinding wheel is bigger, so you can grind the even longer work pieces, you can grind faster, but it has to have heavy structure is required for bigger grinding wheel. So thickness of the grinding wheel is also one of the important specification. Then type of the wheel. So which type of the wheel the grinding wheel. So these are the 5 specifications are required for to specify or to nothing but to buy any grinding wheel from the market or to need to specify the requirement. Then selection of the grinding wheel. So the selection of the grinding wheel, just a few things are there in that. So in selection of the grinding wheel, some constant factors and some variable factors are there. So selection of grinding wheel means, so in your particular application, so you need to have a grinding wheel, right? You have a factory in that, maybe you have some kind of machines are there. So in that, which kind of grinding wheels you need to buy. So how to specify, how we can use that one. So then that's some constant factors. So like properties of the material to be ground. So which type of material you are going to grind, whether it is a soft material or hard material, based upon that your grinding wheel is depends. The amount of stock to be removed. So how much material you need to remove from the workpiece material, whether it is very small material, this is the final polishing you're doing with the grinding wheel, or complete removal of some layer of material you need to remove. So based upon that, you need to choose your grinding wheel. For example, if you take in on welding, when you're doing welding, so whatever the weld bead is formed on the surface on the two joints, two work pieces at the joint at there. So what you used to do, using the grinding wheel or grinding, you need to remove that excess material. So for that is using for removal of the material. So the removal of material means you need to have more material removal rate. But in somewhere to already your surface is already done with smooth with milling or maybe other operation, just you need to do some increase the surface finish. In that case, you need to have a less material removal rate. So you need to be whenever you are choosing any grinding wheel, these all things is matters. Whether you are using the grinding wheel for only for finishing, or maybe you need to remove the material. So amount of stock to be removed. So area of contact of the wheel with the workpiece. So what kind of surface you have, whether it's a circular surface, whether it's a flat surface, whether it's the internal surface. So based upon the location, means based upon the type of area of contacts, you need to choose your grinding wheel. So type of grinding machine and its conditions. Which kind of grinding machine? With a top bench top grinding machine, pedestal grinding machine, or maybe it's a portable grinding machine, and where it is using its condition. So these are the factors, constant factors when you selecting a grinding of any grinding wheel. So there is a variable factors if you take, that is a wheel speed and work speed. So at which speed your workpiece or maybe your cutting tool or nothing but grinding wheel is rotating. So these are the variable speeds, right? It's not a these are not constant. It can be changeable. So if you take in if gear drive, so whatever the motor you have on electric motor, so based upon the controlling the voltage and current, you can change the speed of the grinding wheel. So these are the variable. So this can changeable. So initially whatever the factors are there, those are the constant factor. There's no change in that. But in here you can adjust, you can change it like speed. So dimensional accuracy, how close dimensional accuracy is required for the machine surface, type of grinding to be done, which type of grinding, whether it's the surface grinding or maybe internal grinding. So these things are there. Quality of surface finish. So how best quality you require, speed and feed of the workpiece. So if it is a manual, you need to move, you need to have the manual feed. If it is a moving by machine, so how much feed and how much depth of cut you are providing. So that's also a variable. So depending upon the finish, maybe you can change your feed and depth of cut. And one more thing is method of grinding. So whether the grinding is wet grinding or maybe dry grinding. So based upon that, maybe you can choose your grinding wheel. So why this last method of grinding wheel is important? Some of the bonding material maybe we have seen. So some of the bonding material may not be suitable for wet grinding. So especially if you take a rubber grinding or maybe shellac grinding, which used to absorb the moisture. So if any wet is there, it try to absorb and try to expand. So when it is expanding, so your strength of the wheel is decreasing. At the same time, the specifications of the grinding wheel is also changing. So that's why, so depending upon your conditions, maybe you can choose your grinding wheel properly. So these are the few factors which is required for selection of the grinding wheel. So defects. So now is coming to the end of this grinding. So you supposed to know there is some defects also has happened in the grinding wheel. So how to overcome, and what is that? First of all, defects. So glazing of the wheel. So glazing is nothing but the cutting point of the abrasives have become dull and worn down to bond. So this is what happened. So normally in any cutting tool, in your lathe or maybe in your wood carpentry or anywhere, so after continuously we're using the cutting tool. So after some time, what happened, that whatever the sharp edge is there, that is wear out. That is gradually it is lose its strength and become wear out. Then what you need to do again, you need to sharpen the particular edges. So similarly in the grinding also, so when you are whatever the fine particles you're using, so which is it is placed on the grinding wheel, so it used to worn out after some time. So normally that worn out rate in grinding is very fast compared with any other cutting tools we discussed before this, whether it's a milling, whether it's a turning, whether it is a drilling, any cutting tool if you take. So among them here, because here we used to have very small particles. It's not a very big kind lump of material, or like your drilling bit, or maybe your milling cutter, or maybe your lathe cutter. It's not like that. It is a grinding wheel. To that grinding wheel, these abrasive particles are embedded into it, right? So very small size of the particles are there. So these small size of the particle, when you're exposing it to very high strength, when a very high force is acting on that, then after some time, repeatedly when is acting, what happened after some time, your whatever the sharp edge is there, the sharp edges come out from that grinding wheel and it is fly away. So when these sharp edges are wear out, so then your the whatever the surface is there, the surface reflection will be changed. So these change in the surface reflection is become dull surface is called as a glazing. So to that make the grinding phase of the wheel smoother, and that stop the process of grinding. To make this, once it's become very dull, so what happened, your cutting process will stop, because whatever the sharp cutting edges already wear out because of the forces acting on that. Then what you used to do, you need to, because you need to whatever the wear out grinding your abrasive particles, that abrasive particles has to be removed from this location, and new abrasive particles which is there inside, that has to come and expose on the surface, so that those abrasive particles has to remove the material, right? So that process is called as a dressing. So that is required. So this glazing, so smooth, and that stop the process of grinding. So because if you don't have the sharp edges, you need to have very dull surfaces are there, and nothing but very lump surfaces are there which don't have any sharp cutting edges. Then you stop removing the material. Material may not, even though if you're taking grinding wheel is rotating, but material removal is not possible. So condition in which the face of the cutting edge is acquired a glass-like appearance. So here what we need to do, again you need to make sure your surface has to be get, so whatever the previously starting position, whatever the surface is there, that kind of surface you need to get it, right? So this is grazing. So then sometimes grinding wheel is left loaded, means it is it is weight is become unbalanced. So these are the second defect. First defect is glazing, second defect is left loaded. So cutting faces is found being adhering with the chips of metal. So what happened, you used to have the sharp cutting edges are there when continuously removing the material. So this whatever the material removing from the workpiece, that small layer of the material is may possible to stick in between the sharp edges of the grinding wheel. So because of this, continuously this happening, so the openings and pores of the wheel faces are found filled with the workpiece material particles, or nothing but your chips, whatever the chips are there. Here in grinding, you used to have very small chips. These chips are not like a very long chips in your turning or maybe in drilling. It's very small. So these particles which preventing the grinding action. So what happened? Two sharp edges are there. In between the two sharp edges, if some other material is going and sitting, then what happened? These sharp edges are completely covered with them. So there is no cutting action is taking place. So takes place while this takes place while grinding workpiece of mostly it is soft material. So in soft material, this kind of things is happen frequently. In hard material, this is happened not frequently. It's occasionally happened, but this is happened everywhere. In soft material, it is more frequently it is happening. So these are the two defects is there. So in addition, there are few more defects are there. So to overcome these defects, what you used to do, you need to do the dressing. So grinding wheel dressing is required. So remedy for glazing and loading. So this what we used to do in the dressing, remove the remove the loading and break away the glazed surface so that sharp abrasive particles can be formed again. So what in dressing we are doing, so whatever the worn out, the small grains are there which is worn out and still it is embedded into the wheel, that we try to remove it. When you remove that, so other whatever the sharp edges are inside, because your completely grinding wheel is made of abrasive particles, right? So even if you go wherever you go, there is abrasive particles are there. So this is on the surface, whatever the abrasive particles which is already worn out. So that abrasive particles when you remove, then what happened? The fresh abrasive particles inside it is come onto the surface, and nothing but what new surface, the fresh abrasive particles are there. So these fresh abrasive particles again very sharp and they can remove the material. So this removing the loading and break away the glazed surface so that sharp abrasive particles can be formed again is called, this process is called as a dressing. So dressing is nothing but, so removing that layer, whatever the layer is that glazed layer is formed on the surface, removing that. When you remove the glazed surface, again whatever the inside glazed surface is exposing on the surface of the grinding wheel. This is called as a dressing. So different types of dressing operations are done on the grinding wheel. So dressing with the help of straw dresser. So different kind of tools are there. By rotating this grinding wheel in contact with the tools, maybe it is removing the material. So number of hardened steel wheels with the sharp points on their periphery is removing the material. The total is held against the total work wheel. So maybe this is called as a dressing. So in that, this is the sharp cutting edge which you used to have some kind of projections are there. So this wheel is rotating with contact with the grinding wheel. What happened? These particles, whatever the sharp edges are there, so going and removing whatever the material, whatever the things are unwanted materials are stick into that one, as well as whatever the unsharp particles, the removing the unsharp particles. So once you're running with this, so when contacting this wheel and running together, so then after some time what happened, this is removing unwanted material and again the new surface is coming on. So this process is called as a dressing. Remove loading and break away the glazing surface so that the sharp abrasive particles are again present to the work. So this one layer of material, what happened here is just quite similar to your machining. So what happened, this top layer of the material is removing from the grinding wheel. So when you're removing the top layer, so then again the bottom layer, whatever is there, below layer, that is coming exposing. So in that layer, whatever the abrasive particles are there, so those abrasive particles are as sharp as the starting of the wheel. So this process is called as a grinding. Also calling it the truing. So truing is again one different process, the process of changing the shape of the grinding wheel. So it's become one. So even though sometimes what happened with this warning out, some in the disc, some side it is warning, removing the material is happen, and sometimes it may not happen. So in that case, what happened is changing its shape of the structure. Initially it is circle, so after this maybe it is become some elliptical or maybe some different shape is happening. So again making that to be again the grounding in the same circular shape is called as a truing of the grinding wheel. This is nothing but remedial. So dressing and truing is the remedial, or nothing but rectification of the defects in the grinding wheel. And then there is a balancing. So balancing has to do initially. So balancing of the grinding wheel, maybe we can discuss in this meeting. Okay, fine. We'll see how much is completed. Super finishing operations. So normally, so what happened till now, we are discussing about machining. So machining is nothing but, you know, that it is removing of excess material, or removing of unwanted material. So unwanted material. So once we remove the unwanted material, we need to have some good surface, but still we need to increase the surface finish, or nothing but your appearance of the surface. So normally, if you see whatever the after your filing, so when you're done in your workshop first year, after you finishing your filing, you say your surface finish is looking very smooth, right? By seeing that it's looking like a mirror kind of thing, because it is a metal. That's why you're feeling. But if you touch the surface, so always surface is not very smooth. You can find some kind of very minute ups and downs, you can say. So those things is calling it as a surface finish. So normally this surface finish, to increase the surface in some of the special conditions, maybe I will take just one important call is coming. Give me some. So, three different super finishing operations are there. Those super finishing operations are lapping, honing, and broaching. So these three super finishing operations are performing on that particular equipments or machine. So those machines are we going to learn. So in that you're going to learn about their construction feature. So their basic mechanism of machining and machine time calculations. So these three things we're going to learn from these, especially for these super finishing operations. So first we can see, maybe today's class we are seeing about lapping, and remaining next class maybe we can see remaining two, honing and broaching. So what is lapping? So lapping is also a machining process where we are using abrasive particles. So just now in grinding you have seen, so grinding wheels also made of abrasive particles. So in that, abrasive particles are bonded together by a bonding material and form in the form of a grinding wheel, right? So on the using that grinding wheel, we are removing the unwanted material. But in lapping, so this whatever the abrasive particles are there, so we are not bonding with any kind of bonding agent. So we are not bonding, we are not making in the form of a wheel. So we directly, whatever the abrasive particles, sharp abrasive particles are there, so directly we are using. So directly we are sprinkling this loose abrasive particle on the surface and using a lapping tool. So lapping tool is nothing but a rectangular block kind of thing. So you are holding the on workpiece, we are sprinkling this loose abrasive particles and joining, just holding, applying the force on this abrasive particles by a lap tool. So maybe you can see in this image. So this is a typical lapping process. In that, so maybe you having a workpiece. So here you having a workpiece and you having a abrasive particles are there. So abrasive particles maybe you can sprinkle on the surface, or maybe so these abrasive particles can be flow through one medium. That is maybe some kind of liquid medium or maybe some kind of semi-solid medium. So through this, so these abrasive particles are flowing between the lap tool and the workpiece. So these lap tool is moving forward and backward. So moving far reciprocating motion, or maybe sometimes it's used to have some rotary motion. When your lapping tool is rotating, so this lapping tool is moving this whatever the abrasive particle. When these abrasive particles are moving, for example, you assume this is your lapping tool. So then this lapping tool is moving forward and backward. So this lapping tool is moving this direction, right? Okay. If this direction it is moving, what happened here? So on the workpiece already you have sprinkled some type of abrasive particles already is available. When you're moving this, what happened? So this lapping tool we are moving under some force. When you apply some force and moving this, what happened? Due to this force, these abrasive particles also moving with this. So because of friction and because of pressure, so these abrasive particles also moving along with this tool. So when this is moving, because already it is having some sharp edge, so these sharp edges are contacting with the workpiece and moving forward under this force. So what happened if any kind of uneven surfaces? So if it is a flat surfaces, it's not removing any material, but some kind of projections, if anything is there, maybe you can see on the surface, maybe here some kind of small projection is there, here some kind of small projections are there. So these projections in the terms of microns. So it is not in mm or maybe not in centimeters. It is in the microns. It's usually from ranging of 0.003 to 0.03 mm, means it is 3 microns to 30 microns. it can remove a layer of material which is not more than 30 micron. So only 30 micron means, assume 30 micron means we cannot see from with our naked eye. अगर अपने नॉर्मल आंखों से हम इसको सरफेस अपने को रफ नहीं दिखता, ये अपने को सरफेस हम अगर हम खाली नॉर्मल नेकेड आई से देखेंगे तो इस लुक लाइक ए फ्लैट, हमारे बहुत फ्लैट दिख रहा हो, बट देखेंगे तो उसमें ऐसे थोड़े माइन्यूट एजेस है which is dimension is less than 30 micron. So less than 30 micron normally we cannot see with our eye. So maybe we can feel with this, if you touch with your skin maybe you can feel, but with your eye if you see you cannot see this. So these kind of small edges, small materials can remove using these lapping tools. So simple sprinkling on this, and this is a lapping tool. So under force maybe you can move this lapping tool. So this force may be manual force. If it is a small work pieces and soft material, maybe you can apply with manual force. If this is a hard material or maybe with big surfaces, maybe you can apply some kind of machine force. So using this, you maximum you can remove 0.003 to 0.03 mm means 0.003 mm means, so 1000 mm 1000 micron equal to 1 mm means 0.001 micron equal to 0.001 mm equal to 1 micron. So 3 means it's a 3 micron. So 3 micron level, up to that level you can finish. If up to that accuracy if you want required, we need to go for lapping the process. If you don't want that kind of finish, then lapping is not required. So that's why lapping is considering as a super finishing operation. So whatever the unwanted super finish is required, so unwanted very small thickness of material if you want to remove, then only we need to go for lapping process. So mainly done for mating surfaces. Mating is nothing but contacting surfaces. Normally this kind of operations, lapping process is required wherever you used to have two contacting surfaces are there, like maybe you can see some kind of bushings are there, some kind of bolting is required, when precision bolting is required. So at there, so bolt head is trying to contact with the surface of the workpiece, right? So in that cases, wherever the contacting surfaces are there, so those places we are using this lapping operation. So this is one of the super finishing operations. So here, so lapping compounds is required. So these lapping compounds nothing but diamonds or whatever the things, whatever the abrasive particles we have studied in the grinding. So all the abrasive, any of the abrasive particle we are using, silica carbide, so aluminum oxides. Along with that, maybe you can have some kind of oil or water. So nothing but here, if you see, so this, if normally if you sprinkle on the surface, so these may go into the different positions. That's why what we used to do. So these abrasive particles we are mixing with an agent. We used to call it as a medium. So abrasive particles medium. So this medium we can call it as a vehicle. So we are mixing this abrasive particle in oil or water, and then we are pouring. So this oil and water it is flowing, and when it is flowing through this, so these whatever the lapping tool is applying force and removing. But in some cases, what happened? So these abrasive particles are, maybe you can join with this. So maybe even maybe you can see this is abrasive tool. So this to this abrasive tools, maybe you can directly you can sprinkle. So on this, when you sprinkle on this, what happened? The abrasive particles are stick to the surface. So these sticking abrasive particles, using that, if you're rubbing on this surface, so whatever the size of the surface, uneven surfaces which is there, it is removing the material. So this is called as a lapping process. So lapping can be done by hand lapping or maybe machine lapping. So normally for soft material and smaller cross section area, maybe you can using hand lapping. So lapping compound is spread on cast iron plate and workpiece is moved manually on it. So here, so sometimes workpiece is on the base or maybe workpiece on the top also. So in the manual workpiece, in manual what we used to do, lapping, what we are doing for the small workpieces. Normally we used to take a surface plate, or maybe you used to take very hard surfaces. On that we need to sprinkle this hard particles, abrasive particles, or maybe you can, with slurry of the abrasive particles you are pouring on that, and above that, in holding the workpiece in hand and you are rubbing. So nothing but you are rotating on that, or reciprocating or rotating on that, so that because of the slurry, whatever the abrasive particle present in the slurry, that is removing the layer of the material from the workpiece which is holding on your hand. So lapping compound is spread on the cast iron plate. So cast iron plate is considering as a tool which is giving the strength or nothing but support to the lapping this cutting spread abrasive particles, and workpiece is moved manually on it. So here casting plate is bottom. So maybe if you say here, so this is a casting plate, this is not a workpiece, this is a cast iron plate. So right, so cast iron plate is plating here. On this you are pouring this slurry or maybe abrasive particle, and this is not tool. So now this is as a workpiece. So this is acting as a workpiece. So same thing, process is same only. So here whatever things are they quite opposite. So your workpiece is holding, workpiece is reciprocating, and here whatever your surface plate is there, that is stationary. So in manually, normally this has happened, because in manually you're doing with very small work pieces. The small work pieces you can hold in the hand, and you can just to rub it. This is similar to your process which you have done your MMT in your metrology. So emery paper, just now one student is remember about emery paper. Same thing. This is a kind of emery paper only. In emery paper, the sharp particles are stick to the paper. So in lapping, the sharp particles will not stick to the paper, just simply placed in the on the surface. So what happened in polishing, what you're doing in your MMT lab, you holded your sample in hand and you're just moving on the emery paper. So in hand lapping also same thing. So on the cast iron surface, you need to pour your abrasive particles. So on this abrasive particle, just you need to move your workpiece. You need to rub the workpiece with that. When you're moving front and back, you're removing one small layer of the material is removing. Hand lapping is required high personal skills, because you're doing manually. You need to have high personal skills are required in this hand lapping. The pressure and speed have to be controlled manually, because so experience, or maybe if you want to do properly, maybe in your MMT when you're doing polishing, maybe you've seen if your polishing is not done properly, what happened, your surface whatever is there, it is not coming flat. You need to get some kind, you used to get some kind of inclined surface if you're not done polishing properly. Similarly here also, if you're not holding it properly, if you not control proper speed and its orientation, so your surface may not come smooth, surface may come some kind of inclined surface. That's why in hand lapping, skillness of the operator, skillness of the worker is very important. The lap is made to rotate either in on lathe or honing machine. So in honing, if it is a machining process, maybe this can be this lapping tool, or maybe the tool can be hold in a lathe, or maybe in a honing tool, or maybe that is called as a lapping tool. So you need to hold it, and then it is rotating. Workpiece is reciprocating over its hand. So in manually, maybe over its hand. So large size laps are made of cast iron, while those of the small size made of the steel or brass. So these laps, whatever is there, lapping tools, whatever the hard materials are there, that if it is a bigger size, used to made of cast iron. If it is a smaller size, normally used to made with the steel or brass. So bigger size is used for hard material. Smaller size normally used to use for soft materials like mild steel, or maybe brass, or maybe some copper, right? So extensive use for the finishing ring gauges. So gauges, so the tools which are used to measure the dimensions of the workpiece, to that normally we are using these kind of hand lapping. So in addition to hand lapping, we used to have the machine lapping also. So in machine lapping, so whatever the rotate in previously in hand lapping, so in manual lapping we used to rotate the workpiece or reciprocate the workpiece, but here the rotation or reciprocating is done by machine. That's only the difference. And normally, because we're doing with machining, so even very big workpieces also can possible to lap using machining. So rotating tables is used in place of the plate. So previously, whatever the casting plates you've seen, instead of in place of that, you're using a rotating table. So maybe in this, maybe you can see. So there is a kind of platform is there. We used to call it as a rotating table. So these platforms are nothing but these things are rotates about its axis. So here also, if you say, so this is a lower lap as well as the upper lap, and this is a workpiece, right? So this workpiece, maybe you can keep it in this, and when you're rotating top and bottom, so what happened? This lap tools is in between the lap tool and workpiece used to have the abrasive particles. So these abrasive particles try to remove the workpiece, remove the material from the surface. The workpiece to be wrapped is given a rotary motion by a cage and a rotating on the surface of the table. So this is giving some kind of rotary motion. So this is giving some rotary motion. So this workpiece may be stationary, or maybe workpiece rotating in other direction. So depending upon the accuracy and depending upon the time, so maybe you can have, if it is workpiece is stationary and this is rotating, so maybe your work removal or nothing but your cutting process is faster, but both is rotating. So this is rotating in this direction, this is rotating in this direction. If you take relative velocity is very high, then your machining time is drastically reduced. So depending upon applications, maybe you can choose different kind of machines. Rotating lap is used above and below. So rotating laps, so both are above and below is rotating laps, and workpiece is to be kept in between. So, and this workpiece is going to get the parallel surface. So normally for parallel surfaces, these kind of things are required. So, but if you want to do some kind of curved surfaces and other thing, normally this lapping process may not be useful. So lapping process is normally using for parallel surfaces. So this is a typical your machine surface. Machine lapping process is carried out for gauge blocks. Normally for gauge blocks or maybe for slip gauges. So normally wherever the surface finish and dimensional accuracy has to be very accurate. So normally to that kind of object, now normally if you take the IC engines. So in IC engine, whatever the engine block and cylinders are there, normally for that we need to have a super finishing is required, because in that, whenever the engine block, maybe in thermal engineering you studied about the piston cylinder arrangement, right? So in that, piston and cylinder has to be properly aligned, it has to move properly. So one side you need to have a compression and combustion is taking place. So in that, if you don't have the smooth surface finish, so your whatever the piston and cylinder, it's not exactly contacting. So in that case, what happened, whatever the compressive gases are there, that may leak from the piston and cylinder gap clearance. So normally that is not permissible in IC engine. So that's why in IC engine, whatever the piston cylinder motion is there, for that we need to have a super finishing is required, so that whatever the cylinder and whatever the piston is there, it has to perfectly match, and there is no gap. Even micron level gaps also not there. Even if you're having a micron level gaps also, so whatever the compressed gas are there in the combustion chamber, those things, instead of forcing the piston down, those gases can escape from the gaps in between cylinder and piston. To avoid this, so on this piston cylinder, we used to have some very good surface finishes required. So those kind of surface finish we are going to give using this lapping or maybe in honing operations. So honing is one of the operations where normally using for cylindrical surfaces. This whatever the lapping is there, so lapping is using for flat surfaces, right? So in this, whatever surface is there, whatever the gauge blocks are there, normally even gauge blocks are using for the flat surfaces. But normally honing, the same operation, but only thing here, for if you want to have a circular surfaces, normally we are using honing. So as I told you, I'm not going to discuss honing today. Maybe honing we're going to take in the next class. Now maybe I can stop here with the lapping and honing and broaching. These two super finishing operations, we can going to discuss in our next class. So till now, if students have any kind of questions, please ask me. I try to